Okay, here we go. All right. So here's what I want you to do. On one side, you'll see where I have all the names of the different equipment that you should know in the lab. And then on the back, there's a blank one. It's kind of like a practice quiz. So what I would like you to do is, when you take the quiz on Tuesday, the beginning of the class, most of it's most straightforward. I'll have a picture like this, and I'll say, what is number 6? And you just simply fill in the blank, what's the name of number 6? And then I also have some questions on there, about 5, where I say, I might ask, well, what part is always used with another part? Or if you were gonna do this, what 3 parts would you have to get together, okay? So what I think you should do is make little notes to yourself over here. Like if I tell you what that part does, instead of just sitting here, write a little note to yourself, oh yeah, that's used for this. Ooh, there's one thing I didn't get out. I'll tell you what, I may have to get that out. That's back in that back room. There's one piece I forgot to get out. It's way back in the back corner. All right. No, I had to get it. All right. Everybody ready? So let's start learning lab equipment. And first thing we're going to look at is, let's look at things that are made out of glass. And this is probably the most used piece of equipment in all of chemistry. It's a beaker, and I bet you already knew that was a beaker, yet some people, I don't know why they call it something else, but this is a beaker. This is your workhorse. If I'm gonna make a solution, it's got a big mouth in it, I can do it. I'll do stir things, I can put it on a hot plate. We can do that kind of thing there. So a beaker is definitely most used thing. And next, I'll show you another one. This one could be used, and this is called an Erlenmeyer flask. So yes, you do have to spell it right, but look at Erlenmeyer flask. It kind of looks like a triangle. And an Erlenmeyer flask is shaped, it's got a flat bottom right here. It sits really well there. And it's really kind of like this. It could be used the same way. Now I do want to tell you that these things, both of these, a beaker and a Erlenmeyer flask, they have lines on them that you could use to measure volumes, but I would never do it if I was trying to be accurate, because even the company says plus or minus 5% error. See, they didn't take the time to put that line exactly. They put it about where it belongs. You see that? So if you go up to 50 milliliters, it's about 50 milliliters, but it's not accurate. And so if you just say, oh, I need about 100 milliliters, okay, that's what that's for. But not for measuring accurately. Same thing with the Erlenmeyer flask. You may have an idea about why I might use this one day instead of this one. Any guesses on that? Why would I do that?
So that you can put something in to stop it.
Yes. Wow, that's really good. That's very good. So that introduces a couple more. We could use something like this. We could use a cork to stop it up. And so if I want to keep it overnight and I didn't want evaporation to take place, I could do that, couldn't I? Now, some chemicals, it's okay to put cork in there. Cork's from a tree. It's a bark of a tree, actually, I believe, cork tree. Cork oak tree, and then we also have rubber stoppers. And so you can have rubber stoppers or corks to fit inside the Erlenmeyer flask, like that. Does that make sense so far?
Yes.
All right, so let's talk about another one. Here's another flask that we definitely use a lot in second year chemistry. And I'll introduce this to you again later in the year when we talk about a chapter on how to make solutions. And so when they make solutions, they have to be pretty exact. And this right here is, look, see if you can find the name. Find the name of that on your sheet somewhere. Volumetric. Okay, now this is called a volumetric flask. Now the reason they call it that is it only has one line. You can't see that very well, but there's only one line up there. It only takes one volume. But if I look on the side, it says plus or minus 0.1 milliliters. Now that means that if I'm doing this is 250 milliliters, and the most that this could be off is 0.1 milliliters. That's the most error you're gonna have. Not 5%. See that? This was really tiny. So this is for really, really accurate measuring, but it only measures one volume. Now later when we do a chapter on solutions, I'll bring this out again and show you how to make a solution here. This is called a volumetric flask. then there's an Erlenmeyer flask, and there is a beaker. Those are 3 things so far. Let's keep moving on. All right, now, let's say I want to measure something a little bit more accurately, okay? What if I want to measure liquid volumes more accurately? This is probably the second most used for measuring things like volumes. What's this called? What is this called?
Graduated cylinder.
Okay, graduated cylinder, and what happened is when these first came, we ordered them, they came in a box, and they had these little square hats on them, and had a little tassel, and you had to take those off. No, that's a joke. So they're not called graduated cylinders because of that. It's what we see is it's a cylinder glass, and it has equal graduations. It has equal graduations. When you go to school, kindergarten first, second, third, fourth, equal graduations. That's when you graduate. See that? This is called a graduated cylinder, very highly used for accurate measuring of liquid volumes, like that. Now, here's another one. Take a look, see if you can find this one. This one looks like a glass straw, but it has a lot of marks on it. Okay, now, that's the one I didn't get out. A burette, my advanced chemistry, they were using that for a couple of weeks. And I put them back after they were clean, and I forgot to get them back out. But they're about this long, and they cost a lot of money. They're probably around $80 a piece. And they, take a look at the picture of burette. I'm sorry I didn't bring one out. I'll get one for tomorrow. But the burette, you can put the liquid in there, and it has a little stopcock at the bottom, little thing, a spout thing. And what you can do is you can let liquid come out fast, slow, down to 1 drop at a time, and that's what they do. They were trying to find out how much of this base it took to neutralize this acid. And they had to get exact to the drop, to the very, very drop. And they had to know exactly how many milliliters of base neutralize the acid. And that's called a titration experiment. And so they would use the burette. That's a very, very accurate way to deliver liquid volumes. This is a smaller version of burette, but this one is not used, it doesn't have the capacity of like 50 milliliter capacity. This right here is only like a 10 milliliter capacity. And so this right here is a pipette. So a lot of times in chemistry and biology, when they have something that are kind of like straw-like things, they're called pipettes. Now this is called a graduated pipette because I could do 6.1, 8.2 milliliters. I could be very accurately, and we have these little things here, these pipette pumps, and we can put that on there, and you can actually, I can draw liquid up like that, and I can let the liquid out. And these are probably the cheapest pipette pumps available, and yet some schools don't have any. But if you ever watch on television, you'll see these people take these little things and go like this. They love showing that on TV. You ever seen somebody do that? Those cost about $300 a piece. And when they pull that spring leg thing, exactly maybe 1/100th of a milliliter might come out. And then you see these people all the time. Have you seen it on TV sometimes? Or have you seen, anytime they want to show science, they like to show people with pipettes. Now, have you ever seen a machine where they're showing a college, hey, come to our college, and they always want to show a machine that looks like 4 little eyedroppers are coming out, or 5, and they go, have you ever seen anything like that on TV? Those are pipettes also. Tell me, have you seen these? I'm just making this up.
What channel?
I saw the second one. I don't know what the first one.
I don't know, PBS.
Or TV or...
Okay, all right, that's good. Anyway, this is called a a graduated pipette, but right next door to it is another one, and this one is pretty smart how they did it. Most of the volume is in this big bulky thing, right? But look at the stem. The stem is really tiny, and that's because you get this meniscus. See that? And the smaller the stem, the more pronounced the meniscus. And you could put the bottom of that meniscus right on that line, and it says, it is...
Do they have to blow this glass?
Well, even though when I was in college, we did use blowout pipettes. Nowadays, they don't want you to do that, so they would have pipette pumps. But when I was in college, here's how we did. I did it all the time in microbiology, sometimes in chemistry, and I'm gonna take this off now. And that's what you would do. Would you put that in there? And then you would go like this. But they kind of hesitate now because they don't want people accidentally, swallowing things. I would do that with bacteria or acids. But right now, we're gonna use pipette pumps instead of that. All right, and then the other pipette, the micro pipette, which really is, if I wanted to, there's 1 milliliter, 2 milliliters. It's really rough though. It's a really rough estimate. It's called a micro pipette. It's not a whole lot of difference between that and a dropper. A dropper has no lines whatsoever. This is just a dropper, and this is a micro pipette, and this is a volumetric pipette, and what's this one? Graduated pipette. Okay. All right.
How do they make those?
Okay, so what's interesting is the thing that makes these more expensive is not the glass. It's not the glass. It's how much time it took to put those lines absolutely in the exact place. That's what you're paying for. This thing here actually costs probably around $18. The amount of glass and plastics probably $2. But when they make it, the machine has to carefully paint these on there. Then they go and check it after it dries. They check it with a really, really accurate graduated cylinder. And if somehow that batch, if the lines are in the wrong place, they remelt them and say, don't ship those out. They're not good. They have a thing called quality control. Anyway, there you go. There's a series of that. All right, let's go to the next one. You're going to be using this quite a bit on the next experiment, and everybody knows what a test tube is. And this is not a clamp, it's a test tube holder. Now when you do the test tube, I'll go over all the safety rules again, but real quickly I want to tell you that you would never put this in a flame unless you check over here, and it has 2 words. There are 2 words you look for. One's Pyrex. Pyrex is a real famous type of glass that can withstand intense heating. Some of you have Pyrex baking ware, and you can put in the oven. You can go right from the refrigerator, put in the oven, it doesn't crack. You can't do that with a regular glass dish. It'll crack. Because regular glass, if you heat it too fast, parts will expand faster than the other and it'll shatter. And in that, you can't eat that food. Anyway, so Pyrex, same thing with this. This beaker has the word Pyrex on it also. We're going to be heating with a beaker. So now, let's say you want to hold this test tube, and let's say you want to heat it. So what I'm going to show you here.
Oh, baby.
Butane.
Whoa.
Things are getting serious.
All right, so what we're going to do is, and you'll use, I think there are two of the 7 stations, you actually use a burner. And so I'm going to be looking for safety quite a bit here. What I'm going to do is, the Bunsen burner you see there, a lot of schools used to have that. I had that. But when they started this room here, and they said, we're going to make you a science room, they wanted to know, do you want all the science rooms to have natural gas in them? And I had been at many schools before, and here's what happens. So you have natural gas at every one of these tables. What if I'm not in the room? A bunch of kids come in. I'm not saying it has to be boys, but a bunch of kids come in, and they're just messing around. They don't know what to do. And they're turning the gas on all the time. Turn it on. Yeah. Anyway, so I said, well, and they also told me it was going to cost probably between $50,000 and $60,000 to jackhammer all the floors up, put the pipes down for the gas. And I said, listen, I have a better option for you. These right here, you can buy refill tanks. Every year we buy about $30, $40 of the refill tanks. And how long could it take before you got to $60,000? So we can buy these for the next, almost 80 years to save that. So, and these are also more portable. I can take them anywhere I want. I don't have to have the gas line like that. I don't have to worry about people turning the gas on either. So here's how you use this, all right? This is butane. This is a portable butane lighter. It's going to take the place of the Bunsen burner. I would like you to know what a Bunsen burner looks like, because they said, hey, you took chemistry? You know what a Bunsen burner is? You're supposed to say yes.
Yes, I did.
But and every time you see a Bunsen burner on TV, that's just a classic burner. That doesn't mean every school has it. Yes?
Turn the lights off.
No, that's all right.
Freddie wants.
All right, so here's how I want you to light, okay? We don't need to sit here. I've seen people do this. I don't want you to do this. I don't want you to turn the gas on and go, oh, I don't know how to do this. Oh, I don't know how to do this. And you're just wasting gas. You see that? So what we do is just turn it. You give this light first. See that? Now, we don't put it on top because the gas will blow it out. So you put it to the side. This side, I don't care which side. And watch. just like that. That's how you light a burner. Now, I don't know if you can see this very well, but there's a kind of a blue part and a light blue part here, right? The hottest part of the flame is right about here where the hottest, that's about the hottest part of the flame. Is that a better background for you? No. Okay, so if you're trying to get it hot, heating hot, you do there. Now another thing you would do, and we'll go over all the safety rules again, is if I had something in here that I was going to heat, I see this every year, and I'm not sure why they do it, but people will put this all the way down here, and then they'll heat it, and then they'll drop it. Why?
Because
If the
it
heat ups.
heat.
This doesn't conduct heat that great, but this does.
It's an electrolyte.
And so you put, no,
The
conducting not electricity, conducting heat.
Hey,
All right, now,
hey, you can take it orange.
look again. So what I'm gonna do is, this should be up here, because by the time the heat tries to travel up here, a lot of it dissipates in the air like that. And so another thing you're gonna do is make sure it has Pyrex, make sure your clamp is up here, and then you go like this. You don't need to sit it there like that.
Oh,
Because even though it's Pyrex, there's no reason to intensely heat that little corner right there, you get that? And also, you would never point this at anybody. You would never point it at yourself. You would never point it at someone else. Okay, you put your mask on. All right, anyway, when they shut down, and so you'll be doing this quite a bit, and that's gonna be a little hot. Don't pick that up like this. See, you wanna move it, just pick it like that. Now, right here, what do you think this is called here, this
Test tube
orange thing?
holder.
No, this was a test tube holder. What's this called? Test tube rack. Okay, it's test tube rack. Here we go. All right, now the next thing you're going to be doing, I don't know if you'll do it in this lab, but probably in another lab, is look for it says ring stand. Everybody see ring stand? Now, for a long, long time, I used a ring stand when I was younger. When I went to college, I had ring stands, but really what you're seeing is a more modern ring stand, because ring stands, the bad thing about ring stands, if you put too much weight on them, they fall over. And so what you're seeing is, we're very fortunate to have this. When they designed this, I actually got to meet with the architect way before this was ever built. And they said, what would you like? And I said, I'd like to have a room that had labs on the perimeter with cabinets for glassware, and then the lecture part could be over there. And look here it is. So it's pretty neat I got to design this lab. But another thing we did is, instead of having ring stands, we have this universal stuff. So these poles, see the tapered? See how it's tapered? They can go in there, and that now the ring stand is here, and it's not going to fall over. It's much, much better. We also got this equipment and this equipment for free from another university. All this, we got about, I don't know, $1,500 worth of just hardware for free. So what you do is, you can put this here. Okay, you can adjust it, and so what I'm going to do is I'll use a, this is a ring stand, and this is a ring. Okay, this is a ring or iron ring. And so what we're going to do is put those in there. And I really like it because it's so flexible. I can put it out further or shorter. There we go. And there it is. And now I've set that up. So what would I use this for? Well, one thing I could use it for is I'm going to put this on top of it and see if you can find out what this is called. What's this called?
Wire gauze.
Okay, wire gauze. Okay, there's a wire gauze. I'm gonna put that there because if I wanted to heat a beaker, this is not great. That's not great to do that. You see that? So what we're gonna do is we're gonna put a little platform on it. Here. Now, there is another thing is, if I do have you heat a beaker of water, I'm gonna have you put another ring. I have a series of rings that are kind of small, and I have another series of rings back there that are bigger. And so what I would have you do is put another ring here as a safety feature. You got that? Even though this is kind of steady, I don't want anybody to accidentally get hurt. So if I were to ask you to heat water, I'd ask you to use a ring and a ring stand, wire gauze, and the burner goes down here. And I put another ring here for safety. Everybody get that? All right, so I'm gonna take that apart. Now, what else might you want to heat? What are some other things you might want to heat? So let me show you another thing you might want to do is we have this, and does anybody happen to know the name of this?
The crucible and cover.
Right, and I don't know what year that they used, what year did they read that book? There's a book that you have to read called The Crucible by Arthur Miller. And it has nothing to do with chemistry. But this has been around for a few thousand years. Chemists needed something that you could intensely heat, because they were trying to change one kind of matter into another. And they wanted something that wouldn't shatter when you heat it. And this is made out of porcelain. And so this right here is a crucible, and the book is about a town where a lot of intense discussions going on. It's really intense. And that's why you call it the crucible, because that's where intense things happen. You can see that this would not work very well to heat this crucible here. So we have another piece of porcelain here, and what's this called?
Triangle.
Okay, now real quickly, I'll show you why they call it that, clay triangle or pipe stem triangle. You know, it's weird that for a long, long time, I knew people when I grew up who smoked. My parents smoked. I never did. I never smoked at all. Yet my parents did, and a lot of people did back then. If you go back and watch movies in the 50s, you'll see lots of people smoking. The first show of Andy Griffith, he was smoking. And then they stopped smoking because I guess people, I don't know, didn't like that. But anyway, a lot of people not only smoke cigarettes, some people smoke a pipe, and they thought that was very sophisticated. And so guess what? The pipe had three parts. It had a tip, it had a bowl, and it had something that connected it that could withstand pretty hot temperatures. Pipe stem. And so this is just like a pipe stem. It can withstand high heats, and as you drew the air in, the hot air would come in and then go into this and it wouldn't crack. And that's why they call it a pipe stem triangle. And I'm gonna put that there. And this thing can get so hot that it can be red hot. The porcelain can be red hot. So if you were really, really trying to heat something intensely, you would use a crucible. And they made these especially for that. See if you can find that.
Crucible tongs.
Okay, so here we go. All of this is going to be very hot. So if I want to look at it, all right, how you doing there? All right, so do that. Also, I might want to take it off of the triangle and notice these little, see how it's like that? And they made it just like that so that I could take it off just like that. So you can see that this is made for the crucible. They're called crucible tongs. Now this is not on your, this is actually not on your sheet, but some of you will see these out. I'm gonna have all this equipment out. And these, you can see are not made for crucibles, but they are made for beakers. So these are beaker tongs, okay? All right, let's do a couple more things. This is something that you would probably use. These are made out of glass. It's a glass stirring rod, and you can wash them up really well. So I've used these for years and years and years. And the only thing I want to be careful about when you lay them on a table, make sure they don't roll off from the table and break. See that? Anyway, these you don't want to put them directly in a flame. It's mainly for stirring things. So that's a glass stirring rod. I want to show you another piece of equipment that I might use with the triangle, and I'll use a bigger one here. See if you can find that thing right there. What's that called?
Evaporation dish.
Okay, let's say that you had a solution, and you were saying to yourself, you know what a solution is now, don't you? So let's say it's a solution of sodium nitrate. Let's say, and what if you want to know, say, hey, you know what? How much sodium nitrate is actually in that solution? How would you know?
Evaporate the other stuff.
Right, so we could evaporate the water and leave the sodium nitrate behind. Now that might take days. That might take days. So we could do a little faster by doing this. And there's a piece of equipment that's always used with the evaporating dish. So I could put that solution of sodium nitrate in there, and I can actually heat it. I may not want to go intensely heat it, but I would heat it, and this is called a watch glass. And again, here's one of those old-fashioned names. Everybody used to wear a watch. Now, today's watches are a little different, but before, for almost 80, 100 years, if you had a watch, it had a dome-shaped glass, because if you happen to hit something, it wouldn't shatter it. Nowadays, they have some really strong materials. They can make the glass flat, but for 100 years, everybody's watch glass was shaped like this. So what you do is I turn it upside down, right here, and then I heat it. Now, I don't know if you can see this very well, but the only thing that's going to change to a gas is the water. And see this little lip? The water can escape out here, but none of the sodium nitrate. So I could weigh this to begin with, heat it, evaporate the water, let it cool off a little bit, and then weigh it again and find out just how many grams of a chemical was dissolved in that water. And I could even find out what percent it was. Anyway, that's called an evaporating dish. That's also used with the triangle, which is used with the ring, which is used with the ring stand. Okay, and the last thing is made out of porcelain. Anybody know what this is called?
Mortar and pestle.
Okay. Does anybody know what profession has this as its kind of like its cooking?
Pharmacy.
Okay, now
Restaurants.
even though if you're a really good cook,
Guacamole.
Pharmacist.
you might have one of these. Some of you make guacamole with some of these, but it's a pharmacist. And so what a pharmacist, I know today's pharmacy, it's mainly, you know, they take the pills out, they count it, they look on the computer, make sure that drug doesn't interact with another drug. That's a lot to do right now. But not in the past. In the past, things came in the form of maybe a solid chemical. And you had to chop it up, make it into a powder. And that's what this was for. And so which one's the mortar and which one's the pestle?
Mortar's the.
The mortar's the thing, the smasher.
How do you know?
Because
I
it's
was- yeah.
mortar.
Yes. Actually, I think the
mortar's
Does anybody happen to know?
The mortar's the
Mortar's
bowl.
the bowl.
It is.
Pestle
And
is the
I always remember the pestle is the pounder.
It's golden.
Okay, there you go. All right. So anyway, I've seen people that have these in their homes. They're bigger and they make things like guacamole and this. But my chemistry, advanced chemistry kids, what they would do is we would take some leaves, some green leaves, and we would put them in some alcohol and we cut up the leaves, put in alcohol, and then we might put a little bit of sand in there. And then when they go like this, the sand will pulverize and rip open all the cells. And then the alcohol will dissolve the chlorophyll. So if I was trying to get chlorophyll out of a leaf, I might use a mortar and pestle and some alcohol, and then I could get the chlorophyll out. See that? All right, so that's called a mortar and a pestle. There you go. All right, some other things. You'll probably use this on another lab we do when we get into the mold concept. Sometimes you have, this is a wash bottle, and sometimes you have a precipitate in here, and I need to get the precipitate out. I'm gonna put it into a filtration apparatus. And I don't wanna touch it with my fingers, because then it won't go in there, so I might use this. Of course, you don't wanna contaminate the tip there, so I don't touch anything with it, but I might be able to do that, and that's called a wash bottle there. All right. Another thing you might use, I will say that I haven't used one of these for quite a while. We now have these things called LabQuest. LabQuest is a little computer, and we now have digital thermometers. So if I really wanted to find the temperature of a solution, I probably would use the digital thermometers for that. But this is what an actual thermometer. And by the way, if you get a thermometer like this, if it's anything that's not silver, if it's silver colored, then it's a mercury thermometer. And those are usually the higher quality thermometers, but these are still good. It's not mercury, but anytime you see if it's red, or it's green, or it's purple, then it's colored alcohol. So they have colored alcohol in here, and when you heat it, this is really thin glass down here. You would never want to use that as a stirring rod. So you would, the heat will go into this glass, will heat the alcohol will expand, and it's such a tremendously narrow column here. I'm not sure how they do it. How do you manufacture a column? One day, I had a broken thermometer. I took one of my hairs. It took me 15 minutes with a magnifying glass to get that in that hole. That's how small the hole is. It's like a hair's. And so anytime this expands, it only has one place to go up here. And then, again, why is these expensive? Because they make sure the lines were painted in the right place. So anyway, okay on this thermometer? And again, you'll probably use a digital thermometer there. All right. I forgot to mention this. You guys, if you are in second year chemistry, you would use a burette. Remember, a burette is a very expensive 50 milliliter, very accurate way to deliver it. Now, this is not a burette. I'm going to pretend that it is a burette. How about that? Because I forgot to bring one out. Now, what you do is, this is called a burette clamp. And what it is, they made it so that you could put your burette in there. So if I had my actual burette in there, I could leave there and it would hold it in place, and I could put this on to the ring stand, like that. Okay, now, find out what I have not talked about yet.
Safety
Forceps.
Okay, all right, here we go.
Toothbrush.
Forceps, one of the experiments you're gonna do, you're supposed to pick up a piece of zinc metal, and put it into test tubes. I'd rather you use this rather than your fingers, okay? So these are forceps. Now, they're not tweezers because tweezers have a flat edge on them, and not too many guys know that, but a lot of girls know that tweezers can be used for eyebrows and stuff. And that's why one end is flat. So these are actually called forceps. And if you become a doctor, they won't call them tweezers there anyway. They'll call these forceps, won't they? Many times they have to grab things if you're a doctor like that. Okay, another piece of hardware. This right here is a
Got scrupula.
scupula. I love that word. And so we had just an experiment the other day where they had to get a chemical out of a jar, out of a plastic jar, and not use your hands, so you would use a scupula. And they'll go over to the balance, and they might go like this. They might put it here, and they might go, and they get it like exactly 9.98 grams. That's what they had to do. And so the scupula is used mainly for getting chemicals out. Here's another one. Everybody see that? Okay, and I would use that. I might use that to scrape out something or to grab something. Or one day maybe we'll make really tiny pancakes and just kidding. But when the spatulas you have at home are shaped kind of like that. But that's what these are. And I could use this for a tool. It can be a digging tool or a thing like that. There's a, okay, I did that already.
Yeah.
But there you go. Okay, now let's do another one. I don't think I've talked about this yet, have I?
No.
No, that's
Okay.
not about this.
Now, what's interesting is you can do chemistry in beakers. You can do chemistry in test tubes. You can. And what if I wanted to see like 20 reactions all at the same time? I want to compare the colors if there was a color change. Then I had to have 20 test tubes out here. I could do that. That's a lot of chemicals too. And people started thinking about microchemistry. They started thinking, can we do the same experiment and not use as many chemicals? See, and that's what this is. So what's this called?
24 well played.
But what if I don't have 24 wells?
It's 22 well played.
I have a 96 one back there.
Dang.
So it's really a well plate, isn't it? And these are the wells. And what you would do is, let's say I wanted to compare 5 reactions at the same time. I put them right there, and I'd be able to see it. And that's what a well plate is. Okay, whether it's 24 or not, it's still called a well plate. This is just a lid put on there so it doesn't evaporate.
Oh, shoot. Good time.
Okay, last one. Here we go.
I think,
All right, one more. Ready? One more. Now this, we won't do this in first year of chemistry. Matter of fact, I do it in second year. But if I wanted to produce a gas, let's say I want to produce a gas, I put a tube underwater. I put this underwater, fill it with water, take the lid off. Now it's full of water. Put the tube in here. The gas would come and it would displace the water. And so if I want to do oxygen gas, I could, underwater, I could get a whole jar of just oxygen gas. That's why it's called a gas collecting tube. All right, is there anything else I missed?
Test tube brush.
Test tube brush, that's for cleaning.
Funnel.
Funnel, you know what that is.
Dropper.
And
Safety goggles.
table goggles. Okay, thank you very much. Have a good weekend. Listen, study these. The quiz will be on Tuesday, and then we're going to start the actual part of the lab on Monday. We're going to start doing the lab. Oh, I forgot this one too.
Utility plant.
All right, that's used for everything. That's why it's a utility. All right. Also, if you if one of those papers up there, I know there's 2 people in here, and if it's yours, put your name on it. Put your name on it if it's yours, and put it back on my desk here.
Oh, I forgot to tell you, I cannot, I've been looking all over, I cannot find my packet. And I was wondering if I could have another one if I could.
I might have another one, and also I put it online, but I'll look for one. I have another one.
If you put it online, I can just print it out, but I
You
was.
can, but let me.